Part 4 of Competency 10. In this video, we will answer questions relating to second derivatives. We will also use the same primary derivatives of trig functions and log functions. Number 1, if y equals x to the fourth minus 6x plus 2, what is the simplified expression for the second derivative? Okay, all right, let's get our pen. Okay, so what we need is y double prime. Okay, well, I know that when I get the y prime, that plus 2 becomes 0. And then I'll have minus 6. But then on the second derivative, I know that this term will become 0. Okay, so let me show you. If you haven't done these before, you probably don't really see what I'm doing. Not a big deal. Okay, so we have y prime. And we need to go, oops, ooh. Okay, come on. Erase. There it is. Another delayed reaction. Okay, so for the first term, we have 4x to the third. Then the second term becomes 6. And then the third term is 0. Then when we say y double prime, that becomes 12x squared, and the minus 6 becomes 0. Constants, the first derivative of a constant is 0. So that gives us option B. Okay? And then we apply the same thought for number 2, but it's going to be a little different. Okay? Let me show you how it's different. It's going to take more putting things together. Okay, we could free up a little bit of room here. Let's see here. Let's do that and then go down. Okay. All right. For number 2, if y equals x times 4 to the x, what is the simplified expression for the second derivative? Okay, which is y double prime. Okay, so there's some things that we need to know. First, for y prime, we have y prime. Okay, we will calculate y prime first, then double prime. Okay? Well, we know that these two are multiplied together. So x is our f, and 4 to the x power, that's our g. Okay? So what do we need to do? Well, remember, we are going by f prime g plus f g prime, okay? We'll stay in that format to kind of simplify things, okay? All right, so that means if we want f prime, that'll be 1 times just g as it is. Then we need to add f as it is, which is x, and that will be times g prime, and g prime is, well, let's put it in parentheses, okay? And that will be 4x times ln 4, okay? All right. And if you don't remember that, you can go back to the first of the video, pause that, take a screenshot, okay? All right. Now let's try double prime. All right, well, actually, the best bet here is to clean this up. That's really what we should be doing, cleaning this up so it'll make sense. So what do we have? Well, 1 times 4 to the x is 4 to the x. Then we're adding all that to okay, I see what we're doing here. Well, if we add that and we have, well, actually, sorry, I'm hesitating. But what we really need to do, pull out the 4 to the x. And then we have 1 plus x to the ln 4. Took me a second to see that. So we need to pull out the 4x. Now we have something to work with. And we need to remember that we're multiplying two things together and we're applying the same system or train of thought, the same formula of f prime g plus f g prime. Okay? All right. So this is our f, and all of this is our g. Okay? So that gives us y double prime is equal to. Now, what we do is that gives us f prime. F prime is 4 to the x ln 4. Okay? Then we're multiplying that to g as it is. Okay? Well, I'll just leave that in parentheses then. 1 plus x ln 4. Okay? Then we add that to f as it is, which gives us 4 to the x. Okay, now we have to take, or rather multiply that to the g prime. Okay, and g prime of x ln 4 is simply ln 4. Okay, now, my recommendation is to do some distribution here in the beginning so we can clear things up a bit, okay? And put some like terms together here. Let's see what we've got here. So I will take all of the 4 to the x times this ln 4 and multiply that all I want, okay? So that means I have 4 to the x times the ln 4. Now that's plus, here, let me use a different color. Here. So we are taking all of this and we multiplied it by 1 first. Then we take all of it and multiply it by the second term, okay? So let's see, what do we have? I see 4 to the x times x times, I'm going to put this in parentheses, ln 4 squared plus the 4 to the x ln 4. Okay. What do I see? Well, I see some things that I can pull out. No, not even pull out. I see some like terms. Yep. Let me highlight that. This and this. There are two of them. We should actually put them together. So this gives us 4 to the x power times, yeah, I'll use ln, let me put that in parentheses, okay? We don't need that little dot there. There, well, that was pretty good. Okay, so I bring out, my x. Oh, never mind. I didn't write it correctly in the first place. The middle term. I want to bring it out and write it first, okay? All right, let's see. 4 to the x power x. And then ln 4 to the second, okay? Now I'm going to add 2, okay? 4 to the x ln 4. Okay, so there's 2 of them. I can put them in brackets so you see that there's 2 of them. Okay, regardless, we need to pull some things out. Okay, I'm seeing that we need to pull out the 4 to the x. Okay, notice we're trying to, or remember, we are trying to pull out a common term from both sides of the plus. Okay, so I see 4 to the x power, and we can't pull out the 2, we can't pull out the x, but we can pull out 1. Basically, what we're doing behind the plus sign, we're pulling out all of this, okay, and leaving behind the 2. Over here, we pull out the 4x, we have to leave behind the x, and we have to leave behind one of the ln4s and pull out the other one. Okay, so let me show you what that looks like. All right, that will equal 4 to the x power times ln 4 in parentheses x to the ln 4 plus 2. Okay? Oh my gosh, after all that, is there anything that is similar? Well, definitely not A. No, we have missing pieces in B. C, we have a 4x, we have a ln 4, we have a 2 plus x ln 4. Okay, doesn't matter that, by the associative property, it doesn't matter which one's first, the 2 or the x ln 4. So C, I believe, would be the best fit. And we go to D, there are missing items, missing terms, so that will not satisfy. Has to be C. Okay, now let's look at number 3. Okay, if y equals 2 tangent x, what is the value of y double prime at y equals pi over 4? Okay, so they're asking for a particular value of y at, y equals prime at, well, the first thing that we need to do is we need double prime. I'm saying that we could just, well, no, I'm thinking we use a calculator. That's what I was thinking. I'm sorry, it took me a second. I hesitated. I say we're going to have some calculator use, okay? But we will at least have to find the first derivative. Okay, I also hesitated because I realized that that is x equals pi over 4. So the first thing that we need to do is put our or rather make sure that our calculator is in radians. So you push mode, arrow down, and see where the radian is flashing. That means that we're okay. If your calculator isn't set in radians, go ahead and do that. All right, now then go second mode to back out. Okay, now this is what you need to do. And I am correct in that we only need to find the first derivative, but then I will have to remind you how to put that in the calculator. Okay, this is what we have. Y prime equals 2 secant squared x. Okay? So that's the first derivative. And what we're going to do is when we put it in the calculator, we're going to pretend like that's the first derivative and we're looking for the second derivative. We just need a higher derivative of this. We need the next derivative. That's the first derivative. We need a value, particular value, related to the second derivative. So we just need a higher derivative. Okay, think it out in your brain. We have the first one. The calculator will deal with the rest. Okay, now next issue. How do we put this in the calculator? Our calculator gives us sine, cosine, and tangent. Okay, and does it give us secant? Well, you can always check that if you don't believe it, because there are some things hidden about in your calculator, okay? So what we can do is we can push second catalog, okay? And then we can do, there's our S with our ln button. Then we can say alpha S and enter. Oh, it's not going to, oh, it's going to give us that. Okay, let's try this again. All right. Alpha ln. Okay, now it's not going to go straight to it. My calculator does. Okay, never mind. Let's go back where we're let's just go catalog, and I'll just sit and watch me. I'll arrow up to S for us, okay? I think it's a little shorter if you go from the bottom. Either way, we'll go to secant. See all the things that are in our catalog? Okay, see some of the things. There are things that I haven't used that we won't use, but when you teach, you may use. There's quite a bit hidden. Okay, so there's, see, text, color, all kinds of great things. Okay, now notice that we have tangent, we have hyperbolics, yeah, and some of these things we've used. String, standard deviations, we need SEC. There's TQ. Nope, there is no way to get our secant, but that's not a big deal. I just wanted to show you some of the things that were there. Okay, so, and sometimes I forget which calculator I'm using. I'm like, okay, does the TI-84 have this versus, other things that I use? And sometimes I actually have to go looking. If I only use the TI-84 in my world, sure, I would probably remember, but I don't always. I use many, many other applications. Okay, so that's a way to go look. So second mode, we know we're good. Okay, I don't care. What we're going to do is push Y1 or Y equals. Now look at what I have. I have in our, see how I have second tangent? Now look at what I have here. I have put in 1 over cosine squared. Well, that's really what we need here. Let me clear all this out, and I will write it. And looks like I was doing something else similar. Okay, so in the calculator, the same equivalent trig function is 1 over secant. Oh, not secant. Sorry. I was just copying what I was writing. Okay. It is actually cosine x, and we square it. Okay. So then in the calculator, you will have 1 over cosine squared x. Okay. And that will give you the exact same graph, and we can find what we need. We can get our x equals power of 4. Let me show you. Let me prove it to you. Okay. You can watch what I do and then see what we've got. Okay, so I have 2 times. I'm going to go ahead and get our fraction. So alpha window, arrow over, and I'm going to work with number 1 to put in a fraction. Okay. Oh, it put in our 2. Put a 1 over there, bounce back over, put in our 2. Yeah, it auto-populates, and I forget that. Okay, so let's say cosine, put in our x, close our parentheses, and now let's do to the second power. That's the same thing if you remember. Okay, so now we will graph this. Okay, what did I put in wrong? Well, that is 2. Okay, let's All right, second window, arrow over, keep it here. Well, 2 times 1 is 2. Okay, 2, go down and say cosine x, and then square it, and let's graph. There it is. I was like, I knew it'd graph fine. I've graphed it before. Okay, this is what we need. But this is the first derivative. But if you remember, the next higher derivative, the next derivative will be second trace, number 6. Okay, what do we need to enter? Pi divided by 4. So that's second, caret up. Okay, caret up. And how if I pushed it hard enough? And divide by 4. There's our value. Push enter. Voila, there's our number. It would be 8. If you see where I've got my pen, remember the 0.0000 and then some random numbers. This is like a calculator error situation. We ignore that. We go with the whole number, okay, which is the 8, option C, okay? Now, that is kind of a quick way to do it. You can, if you want, you could find the second derivative by hand, which would be this. Y double prime equals 4 secant x. Okay, now let's look at what I'm doing. If you go from the inside out, the outside is going to be, hang on, I got that in the way. Okay, the outside will be 2 times 2 is 4, and then this is what we have. But now we have to say, well, what is the first derivative of secant? And that will be multiplying secant x times tangent. Well, that is 4 secant squared x tangent x. Okay? So this is y double prime. Okay? All right? And you can put that in the calculator with actually substituting in pi over 4 for each, okay? Either way, you get the same value. I've done it both ways. Calculator was just a little quicker. Only get the first derivative, put it in the calculator, look at your graph, and enter accordingly. Okay? All right, so let's look at number 4. What is the critical point? Okay, and let's go down and make some room just a bit. All right, and I can erase this. Okay. All right, what is the critical point of f of x? And here's our function. Basically, there's a couple ways to do this. You could get the first derivative and then set it equal to 0 and solve. There is no need for us to do that, and I'll tell you why. We can just simply put it in the graph, okay? All right, so second mode to back out. Now, f of x, I will clear the first one, and we have 4x squared, okay, minus 16x plus 1, and let's look at the graph. Okay, we can change the window really quick or just zoom out. Let's zoom out a bit. I'm going to go down a little and then over. Yeah, there it is. Okay, just a little, and now I'm going to push enter. See how it backed out? Yeah, I don't like that either. Zoom in. I think it was probably better just to change the window. Okay. No, I just want plain window. Second mode. Sorry. Graph window. Ooh. Okay, let's see. I want a minimum. I would like to only deal with my minimum of y. And let's see. I'm going to say negative. Let's clear it out and say minus 15. Okay, now let's graph. Okay, much better. And it looks like we have a minimum at 2. 2. I will not count all of these uh points here count, along my y-axis. I'm going to say second graph to get my actual table. And I know that I need to go to 2. X equals 2. Oops, it's right there. And that tells me that it's 2 and negative 15. Okay. Oh, looks like when we made room, we got rid of one of our answers. There it is, 2 and negative 15. Okay. All right, there we go. All done on the calculator. Okay, no need to go through the written values. However, you'll see when we answer other questions, we will have to find the first derivative, second derivative, and so on. Okay, now let's say that our equation was not as cooperative. Our graph, because of the way the equation was, we couldn't see much. We just couldn't see what we needed. Okay, it was very hard to tell. So what you can do is you can get f prime of x, okay, and set it to 0. So that will be 8x minus 16 equals 0. Okay, this is how you find critical points. What I'm doing is I'm finding the value of x, so we have 8x with a bit of algebra. Okay, divide both sides by the 8, and this gives us x equals 2. And that will tell you where to go in your calculator, which we have the table up. Then you bring up your table and do what we did, okay? All right, let's go on to number 5. Number 5, what are the critical points of f of x equals negative x to the third plus x squared plus 5x? Okay, sure, we could find the first derivative. I'd rather graph it first and see what's going on. So let's go to our um, y equals, okay, so what I pushed y equals, all right, and I cleared it out. So now we need to enter our function, negative x, caret up the 3. Now for this one, you have to arrow over. Remember, when you use the caret up, you have to physically push your left arrow. Okay, now plus x squared, and notice the difference, it pops right over there for you. Okay, then plus 5x, okay? Now let's graph that. Okay, now of course I moved my window around. So let's push window and let's go back. We have a minus 15. Let's go to a standard window. I'm going to back out of that and I'm going to say, let's go graph again, zoom. Let's do a 6. Let's go to number 6. Okay, yeah, see that pops back without me messing with it. Kind of an automatic window. Nice and convenient. Now, what do we have here? I think I'm seeing a minimum. Looks like it's at -1, -3, and a maximum x value somewhere between 1 and 2. Okay, so let's use our table. Second graph to get our table. All right, now, and looks like I have, okay, we're going to have to change these settings. Notice how I have everything in a decimal form. Everything's with a half. Let's change that. I see that my A, B, C, and D, my options are either integers or I see fractions. And what's important here on these fractions is the x values here. Now, they could be different. let's say they weren't all exactly the same. Let's say that I notice they're all um, third. The denominator is all 3. They're in increments of a third. Okay. So I see 5 over 3 is our x, which I'm going to try that. Okay. So what do we need? I am going to say second window to set the table. Well, I know that it's pretty likely that I have a minimum, at least a local minimum at -1, -3. I disagree with B. That's not a minimum. Over in that first quadrant, I'm going to say that that's a maximum. So I disagree with this one, and I disagree with this one. Okay, I'm not agreeing. But I need to find out if my other point is accurate. Okay, well, they're all the same. They aren't always. They could have changed them. Okay, so let's deal with this. So I'm going to go, let's say around 1. I'm going to start my table at 1. That's, see how it says table start? I'm just starting at 1. I'm not changing anything. But over here, I'm going to clear this. And I am going to push 1 first, then alpha window, arrow to the left, and I want number 1 highlighted, what we've been using. Push enter, and then I'm going to stick a 3 under there. And it looks different, but it does make a difference, okay? Now, I like to push enter just for safety's sake. Okay. Now we go back to the table. Second graph. It does make a difference. Imagine that. Now, we need to go to our 5 over 3. And there's our numbers. Perfect. The first time I did this, I was so excited. I'm like, all these years, no one told me this worked, and it does. So that's one way to compare. And on all of our options, the second point here, they are all exactly the same. I guarantee you that will not be the convenience on a practice test or your actual state test. There'll be different second points. So, but the calculator tells us I'm not doing anything else. I have my value. Okay. So now let's go to number 6. And I was just looking at, we have some same values. Okay. I want to make a point here. You may know how to do this or you may not. Okay. Number 6 uses the equation that we had prior. But then we go to number 7. I'm noting that it's the same function that we have in our calculator right now. Okay, I'm not taking that out. Probably shouldn't have taken the other one out either. This is what I'm going to do. Second mode to back out. I'm going to go back to my y equals. Now, arrow over. See where our equals sign is in black? It's kind of highlighted in black. I'm going to arrow to the left on top of it, and I'm going to push enter. That temporarily turns it off. Okay. And then we can turn it back on when we go to number 7 and then turn the one we're about to put in, we can turn it off. So you can actually store several equations and simply turn them on and off. It's not a habit that I'm into during videos because I like to show people what I'm entering. But you will see me do more of it. Okay, so what do we do? We can arrow down and then we arrow down, push enter to turn. Okay. Oh, that's right. We have to enter the equation and then go back. Yeah. So let's enter our function. Okay. So we are entering 4x squared. Okay. Minus the 16x plus the 2. Now arrow back. Now, oh, it's on. Automatically turn on. Okay. Awesome. All right. Now, but you know what? I'm going to do it real quick just to show you. See, we can turn it off. Then we can go up and turn the other one on. Then we can hit enter again to turn it off, go back down, and turn that one back on. Okay, so we have that on. Let's push our graph, see what we have. And yes, it's obviously on. That's the graph we had earlier when I changed the window around. Now, from looking at our graph and what I did earlier, we can answer this question. It says using the slopes of tangent lines for this curve, determine if the critical point is at 2 minus 15. Oh, determine if the critical point is a maximum or a minimum point. I'm not doing that. I'm just going to be honest with you. My calculator is giving it to you. I'm in the middle of a test. There's no way I'm going to pencil all of that in. Okay. You're more than welcome to practice it, not for my videos. My videos are meant to show you what's best in the calculator and how quick you can get your answer. Obviously, it's option B, a minimum point without a shadow of a doubt. Okay. And here's another clue. Your leading coefficient is positive, and this is a basic quadratic. You know there's going to be a minimum. I mean, by this time in your academic career, you have seen so many of these that it's captain obvious. However, a test question will not be so obvious. Either practice or real. It will not be obvious. This is just, kind of getting you going. Okay. That being said, let's back out. Oh my gosh. Okay. Too many pushing of buttons. Now, what do we need to do? Like I said, turn on our first Y1, turn off our Y2. Now graph, and we should be back on the proper graph for number 7. Okay. And let's read number 7 before we do that. Using the slope of tangent lines for the graph of, that's our graph, determine our function, determine if the critical points, those are the prior critical points that we had before, are maximums or minimum points. We already knew that answer. Push graph. Okay. Now, there may be a question asked differently where you will need to deal with a tangent and do this. And we have worked with tangent lines in other videos. We will continue working with them as we practice. But for our purposes right now, we know that -1, -3 is a minimum. So mark out anything that says maximum. Okay, so that gets rid of this one and this one. Okay, so then this one is a minimum. This one is a minimum. Now, the next higher point, the next point is a maximum. Okay, and that would be A. C says that it's a minimum, and that is incorrect. So it must be A. That is our value. Okay, this is the last question in this video, and I hope you enjoy my little, well, sometimes I get a little stuck or distracted at what they're trying to ask us, but either way, regardless, I hope that you're learning something, that you're taking something away from these videos and that it's helping you out. And if it really is helping you or you think it'd help someone else, please share us, like us, and don't forget to subscribe. Happy testing.